I am Radhakrishna, mathematics teacher. Today we are going to continue our topic quadratic equations and expressions. First we will solve few problems, then discuss some theory, again problems. Okay. If the equation x square minus x minus n is equal to 0, where n is a natural number less than 100, has integral roots, find the number of values of n. Usually for real roots or imaginary roots we use the discriminant, but for integral roots, when it is said that the equation has integral roots, the approach should be completely different. What we do is we write the equation as x square minus x is equal to n, that equation, and further you can write x square minus x as x into x minus 1 is equal to n. Now if x is an integer, since the equation has integral roots, x is an integer. If x is an integer, what happens? N is a product of two consecutive integers. X into x minus 1 is the product of two consecutive integers. So what are the values of n? N is equal to, starting from the smallest numbers, smallest consecutive numbers are 1 into 2 or 2 into 1, 2 into 1 or 3 into 2, 4 into 3, and what is the last pair here? It is definitely 10 into 9, 90. That is the last value of n. If you go further, it becomes 11 into 10, 110, it is exceeding 100. So how many values of n are there? Starting from 2 into 1 to 10 into 9, 9 values are there. Number of values of n is equal to 9. Okay. Next question, find the integral values of a for which the equation x plus a into x plus 10 plus 1 is equal to 0 has two integral roots. Again the approach is different. You can write that equation as x plus a into x plus 10 is equal to minus 1, taking 1 to right hand side. You can write it as x plus a into x plus 10 is equal to minus 1. Here x is an integer and we want the integral values of a, so a is an integer. X is an integer, a is an integer, so x plus a is an integer, x plus 10 is also an integer. Then it is product of two integers, not consecutive like previous question. It is product of two consecutive two integers is equal to minus 1. But we know that minus 1 can be expressed as a product of two integers only in only two ways. What are the ways? We can write it as minus 1 into 1 or 1 into minus 1. Only two ways are there. So if you take the first case, x plus a should be equal to minus 1, x plus 10 should be equal to 1. If x plus a is equal to minus 1 and x plus 10 is equal to 1, from x plus 10 is equal to 1 we get x is equal to minus 9. Substituting x is equal to minus 9 here, you will get a is equal to how much? 8. So one integral value of a is 8. Now what is the second case? 1 into minus 1. So x plus a should be 1 if x plus a is equal to 1 and x plus 10 is equal to minus 1. Then from the second equation we get x is equal to minus 11. Substituting x is equal to minus 11 here, you will get a is equal to 12. So, we got both the integral values of a for the question. Okay. Next question. If alpha and beta are the roots of ax square plus 2bx plus c is equal to 0, and alpha plus k and beta plus k are the roots of capital Ax square plus 2 capital Bx plus capital C is equal to 0, then what is the value of b square minus ac with small letters divided by b square minus ac with big letters? Options are given. First, you notice that k is added to each root. If k is added to each root, the roots are a plus k, alpha plus k, beta plus k, then the sum will change, product will change, but difference of the roots will not change, is it not? So, let us take difference of the roots in both the equations and equate them. Mod alpha minus beta is equal to, what is that formula for difference of the roots in any quadratic equation? We have to take the formula mod root delta by mod of a. This is the formula for the equation ax square plus bx plus c is equal to 0. Now, for the first equation, what is it? Root over 4b square, 2b whole square, 4b square minus 4 into a into c, minus 4ac by mod a means here x square coefficient is a only. So, mod a, it should be equal to difference of the roots in the second equation. So, what is the formula? Root delta by mod a. Root delta is 2 into big B whole square, 4b square minus 4 capital A into capital C by mod capital A. Now, we have to simplify, cancel the square roots, squaring on both sides, you will get 4 into b square minus ac by a square is equal to RHS, 4 is common, 4 into b square minus ac with capital letters by capital A square. Now, cancelling 4 and cross multiplying, we get b square minus ac upon capital B square minus capital A capital C is equal to what? Small a square by capital A square. So, what is the answer? Option A is correct. Next question. Yeah, after finishing the few questions, now we are going to discuss some theory. Suppose alpha and beta are the roots of f of x is equal to ax square plus bx plus c is equal to 0. The quadratic expression ax square plus bx plus c is denoted by f of x. Then, suppose the roots are transformed into another form, but both the roots must be changed in the same manner. Then automatically the quadratic equation will change, and the new quadratic equation with the transformed roots is called transformed quadratic equation. Now, I am going to give you a table in which we will have a list of transformed roots and the corresponding transformed quadratic equations. Now, let us see. Ax square plus bx plus c is equal to 0. Its roots are alpha, beta. Now, let us suppose a constant k is added to both the roots. Then new roots are means transformed roots are alpha plus k comma beta plus k. If a constant k is added to each root, then how to get the transformed equation? I will tell the general method. Assume that any one of the new roots is some y. Let y be equal to alpha plus k, or you can take beta plus k. Then alpha or beta will be equal to y minus k. Is it not? Now we know that alpha and beta should satisfy this equation. That means y minus k should satisfy this equation. So substituting y minus k in the given quadratic equation, you will get a into y minus k whole square plus b into y minus k plus c is equal to 0. Okay. Now it is a quadratic equation in y. If you expand the square and simplify, you will get a quadratic equation in y. There will be one y square term, one first degree term in y, some constant term. So in this quadratic equation, what is y? Y means alpha plus k or beta plus k. So this is the quadratic equation whose roots are alpha plus k and beta plus k. But you should write the final answer in terms of x only. Therefore, the transformed equation is a into x minus k whole square plus b into x minus k plus c is equal to 0. If this is represented by f of x, then what is this equation? You have replaced x by x minus k. So this is f of x minus k is equal to 0. Just observe the method. If you want to add k to the roots, k to each root, what you are doing? You are replacing x by x minus k, means you are subtracting k from the variable x. Okay. Similarly, suppose you have subtracted k from each root. New roots are alpha minus k, beta minus k. Then if you follow this procedure, finally what will you get? You can easily guess. You will replace x by x plus k. The transformed equation will be f of x plus k is equal to 0. Okay. Similarly, suppose the new roots are k into alpha, k into beta. So you have transformed the roots by multiplying each root by k. Remember, you can follow this method for getting the new quadratic equation when the roots are transformed only when both the roots are transformed in the same manner. If you multiply this by alpha by k, you should multiply beta by k, then only you can get this. Now, if you multiply each root by k, you can easily guess what is the opposite process. So when k is added, k is subtracted from x. When k is subtracted from the roots, k is added to the variable x. Similarly, if k is multiplied here, you have to replace x by k. You have to divide x by k. So the transformed equation will be a into x by k whole square plus b into x by k is equal to 0, which can be written as f of x by k is equal to 0. You follow the same steps, you will get it. Is it not? Similarly, if you divide each root by k, then what will be the transformed equation? You can easily guess. You should multiply x by k. So we should replace x by kx. So the transformed equation will be f of kx, f of kx is equal to 0. Okay. Suppose I want to multiply the roots by some number L, then they will become L alpha, L beta. Now I want to add m, I am doing both. If the new roots are, or transformed roots are L alpha plus m and L beta plus m, then if you follow this method, what will get? See, same steps. Let y be equal to any one of the new roots, L alpha plus m or L beta plus m. Here L and m are constants. Then calculate alpha or beta from this. Alpha or beta will be equal to y minus m by L. Is it not? Observe. Alpha is equal to y minus m by L. So, since alpha or beta must satisfy this equation, you can replace x by y minus m by L. So, the transformed equation is now replacing y by x. The final answer is a into x minus m by L whole square plus b into x minus m by L plus c is equal to 0. That is f of x minus m plus L is equal to 0. Okay. And similarly, if the roots are suppose squared, if the roots are squared, new roots are alpha square and beta square, then y will be, if you take y is equal to alpha square or beta square, then alpha or beta will be equal to what? Plus or minus root y. Then you can replace x by plus or minus root y. So, you will get ya into plus or minus root y whole square plus b into plus or minus root y plus c is equal to 0. Then replacing y by x, a into plus or minus root x whole square plus b into plus or minus root x plus c is equal to 0. But this is not a quadratic equation because root x is present. So, we have to modify this into a quadratic equation, taking this term to right side and squaring. See, this is plus or minus root x whole square is x. So, ax plus c is equal to, taking this middle term to right side, you will get plus or minus becomes minus or plus b root x. Squaring on both sides, you will get ax plus c whole square is equal to b square x. This is the quadratic equation. Or you can substitute root x and 1 minus root x separately and multiply, then automatically you will get this answer. So, the formula will be, when roots are squared, the new quadratic equation is f of root x into f of minus root x is equal to 0. Automatically you will get the same answer. Now, I am going to give you a table for all these transformations. See, these are the transformed roots, these are the transformed equations. When roots are transformed like this, alpha plus k, beta plus k, new transformed equation is f of x minus k is equal to 0. Just opposite process. Here If alpha minus k, beta minus k are the new roots, the transformed equation is f of x plus k is equal to 0. If k alpha k beta, then f of x by k is equal to 0. If alpha by k, beta by k are the new roots, f of kx is equal to 0. If L alpha plus m, L beta plus m are the new roots, the transformed equation is given by f of x minus m by L. If alpha square, beta square are the new roots, then f of root x into f of minus root x is equal to 0. Okay. Now, let us solve few questions. If alpha and beta are the roots of the equation 2x square plus 3x plus 5 is equal to 0, find the quadratic equation whose roots are 2 alpha plus 1 by alpha minus 1, 2 beta plus 1 by beta minus 2. I have explained the table only for the procedure, but the transformation can be anything like this. Then we have to follow the general procedure and find the answer. Okay. Here let us write the quadratic equation 2x square plus 3x plus 5 is equal to 0. Its roots are alpha and beta. Now, new roots are what? 2 alpha plus 1 by alpha minus 2, 2 beta plus 1 by beta minus 2. New roots are 2 alpha plus 1 by alpha minus 2, 2 beta plus 1 by beta minus 2. I will take any one of the new roots as y. Let y be equal to 2 alpha plus 1 by alpha minus 2. What should I do now? I should calculate the old root from this. Old root means alpha. Cross multiplying, we get alpha y minus 2y is equal to 2 alpha plus 1. And taking 2 alpha this side and minus 2y that side, you will get alpha into y minus 2 is equal to 2y plus 1. Then alpha is equal to 2y plus 1 by y minus 2. Now, alpha is a root of this equation. Therefore, I will substitute 2y plus 1 by y minus 2 in place of x here. So, 2 into replace x by 2y plus 1 by y minus 2. 2y plus 1 by y minus 2 whole square plus 3 into 2y plus 1 by y minus 2. Plus 5 equal to 0. We have to simplify. Don't replace y by x directly. After simplification we will do that. Multiplying both sides by y minus 2 whole square, it becomes 2 into 2y plus 1 whole square plus 3 into 2y plus 1 into y minus 2 plus 5 into y minus 2 whole square is equal to 0. Simplify further. 2 into 2y plus 1 whole square is 4y square plus 4y plus 1 plus 3 into multiplying these two 2y square minus 3y minus 4y plus y minus 3y minus 2. Finally, plus 5 into y minus 2 whole square, y square minus 4y plus 4 is equal to 0. Now, I will write the next step directly. First collect the terms of a y square. 8y square here, 2 into 4, 8, 8y square here plus 6y square. 8 plus 6, 14 plus 5y square. 14 plus 5, 19y square. Next, coefficient of y. Here 2 4s are 8y, here minus 9y. 8y minus 9y, here minus 20y. So, it will be minus 21y. Now, constant 2 into 1 2, minus 6 here, 3 into minus 2 minus 6, 2 minus 6 plus 20. 2 minus 6 plus 20 is 16. Is it not? Therefore, the transformed equation is just replace y by x. You will get 19x square minus 21x plus 16 is equal to 0. This is our answer. Okay. Next question. If 2 alpha plus 3 and 2 beta plus 3 are the roots of this quadratic equation, find the equation whose roots are alpha by alpha plus 1 and beta by beta plus 1. Here I have slightly changed the question. Initially in the previous question, alpha and beta are the roots of the given equation. Find the equation whose roots are the transformed roots. But here even roots of this equation are also given in transformed form. Okay. So, what we should do, as usual, we take the new roots as y, either alpha by alpha plus 1 or beta by beta plus 1 as y. Then let alpha by alpha plus 1 be equal to y and calculate alpha. Cross multiplying, alpha is equal to alpha y plus y. Then taking alpha this side, alpha into 1 minus y is equal to y. We get alpha is equal to y by 1 minus y. In the earlier question, alpha is a root of the given equation. So, we have substituted. But here roots are 2 alpha plus 3 and 2 beta plus 3. So, we have to calculate 2 alpha plus 3 here. 2 alpha plus 3 is equal to multiplying by 2, 2y by 1 minus y plus 3. Simplify it, 1 minus y is LCM. Numerator will be 2y plus 3 minus 2y. It will be 3 minus y. Correct? So, now 2 alpha plus 3 is a root of that equation now. So, this must satisfy the equation, given equation. I will substitute. What is the given equation? 3x square minus 2x minus 7 is equal to 0. Given equation is 3x square minus 2x minus 7 is equal to 0. Then substituting this, 3 into 3 minus y by 1 minus y whole square. I can write 3 minus y by 1 minus y as y minus 3 by y minus 1. Okay. I will substitute y minus 3 by y minus 1 whole square minus 2 into y minus 3 by y minus 1 minus 7 is equal to 0. We have to simplify. Finally, I have to replace y by x. How to simplify? Multiply both sides by y minus 1 whole square. Then 3 into y minus 3 whole square will be remaining here. Second term becomes minus 2 into y minus 3 into y minus 1 multiplying by y minus 1 whole square minus 7 into y minus 1 whole square is equal to 0 into y minus 1 whole square is 0. Now simplify 3 into y square minus 6y plus 9 minus 2 into multiply these two y square minus 4y plus 3 minus 7 into y square minus 2y plus 1 is equal to 0. Collecting second degree terms 3y square minus 2y square minus 7y square. So, it will be minus 6y square. Next first degree term minus 18y, 3 into minus 6 minus 18y plus 8y, minus 18y plus 8y is minus 10y, here plus 14y, 10y plus 14y is 24y. Now constant 3 9s are 27 minus 6, 27 minus 6 21, here minus 7, 21 minus 7 14, plus 14 only, no. Now you divide by minus 2, then 3y square minus 12y plus 7 is equal to 0. Okay. Is this correct? Let us check. Minus 18y, minus 18y plus 8y is minus 10y, minus 10y plus 14y, minus 10y plus 14y will be 4y. Okay. If I do any calculation mistake, you understand the method only, you can correct the calculation, you can observe the calculation mistakes if any, because being this is a live, so we also make some silly mistakes. So the calculation part you can ignore. Okay, again you can recheck the calculation and get the correct answers. Okay. Now dividing by 2, you will get this equation. Now what is the transformed equation? Replacing y by x. The transformed equation is 3x square minus 2x plus 7 is equal to 0. Okay. Let us move on to the next question. Alpha and beta are the roots of x square plus 2x plus 5 is equal to 0. Then find the equation whose roots are alpha plus 1 by alpha, beta plus 1 by beta. It is the same model, just I will write direct steps and get the answer. So replace taking this as y. This is 1, alpha by alpha 1 plus 1 by alpha. So we will get 1 by alpha is equal to y minus 1, y is equal to 1 by y minus alpha, alpha is equal to 1 by y minus 1. So you have to replace x by 1 by y minus 1, or you can replace x by 1 by x minus 1 directly. 1 by x minus 1 whole square plus 2 by x minus 1 plus 5 is equal to 0. Multiplying by x minus 1 whole square, you will get 1 plus 2 into x minus 1 plus 5 into x minus 1 whole square is equal to 0. first second degree term is 5x square. Here you will get minus 10x, coefficient of x will be minus 10 plus 2. So, minus 8x. So, no need to calculate the constant because only one option is matching second option. So, automatically you will get plus 4 is equal to 0. So, correct answer is second option. Next question. If alpha and beta are the roots of ax square plus bx plus c is equal to 0 and c not equal to 0, the equation whose roots are 1 by a alpha plus b and 1 by a beta plus b is. And the roots are transformed in the same manner. So, you may proceed just like previous question, but here we have an alternate method. We can simplify the transformed roots. How? Alpha is the root of the given equation, no? So, alpha satisfies the given equation, a alpha square plus b alpha plus c is equal to 0. From this, take alpha common from the first two terms and take c to right hand side. Then you will get alpha into a alpha plus b is equal to minus c. Similarly, beta also satisfies the given equation, no? So, substituting beta, a beta square plus b beta plus c is equal to 0, and taking beta common from the first two terms, beta into a beta plus b is equal to minus c. Then from this, what is the value of 1 by a alpha plus b from this equation? 1 by a alpha plus b will be minus alpha by c. From this equation, 1 by a beta plus b will be equal to minus beta by c. Now, we proceed with the procedure. Take the new root as y. Then what is the old root? Alpha is equal to minus cy. So, alpha satisfies the equation now. So, you have to replace y by x by minus cy, or you can directly replace x by minus cx. So, what happens? C into, a into minus cx whole square plus b into minus cx plus c is equal to 0. You can cancel c. First you write minus cx whole square as c square x square, a c square x square minus bcx plus c is equal to 0. Since c is not equal to 0, you cancel c. You will get ac x square minus bx plus 1 is equal to 0. This is the transformed equation. What is the answer? Fourth option is correct. Okay. Next question. Now, we are going to discuss some more theory. Common roots. It is a very, very important area of this chapter. If the two quadratic equations a1x square plus b1x plus c1 is equal to 0 and a2x square plus b2x plus c2 is equal to 0 have a common root, then you have to remember this. First I will explain how to solve. First I will explain one method that is called Cramer's rule. This Cramer's rule is used to solve simultaneous equations. Let us take two simultaneous equations in x and y. A1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. You want to find x and y. Then we can follow this Cramer's rule and solve the equations comfortably. The method is write the coefficients of x, y and constants in two rows. First row a1, b1, c1, second row a2, b2, c2. After writing, you repeat the first coefficients, that is a1, a2. Now take arrows like this. Then what is this? This is called determinant, a1 into b2 minus a2 into b1. Along the downward arrow you have to multiply the numbers and take plus sign. Along the upward arrow you have to multiply the numbers and take minus sign. a1 b2 minus a2 b1, it is called determinant. Let us denote this determinant by d1. Similarly, this is also a determinant, b1 c2 minus b2 c1, denote it by d2. Next determinant is d3. Now you write x by first unknown is x by d2 is equal to second unknown is y by d3. Say x by d2 not d1 plus y by next determinant d3 is equal to, next is c1 into constant it is, so take 1 by d1. Then x is equal to d2 by d1, y is equal to d3 by d1. So you got the values of x and y. This is called Cramer's rule. Now let us take the given quadratic equations. a1x square plus b1x plus c1 is equal to 0. a1x square plus b1x plus c1 is equal to 0 and a2x square plus b2x plus c2 is equal to 0. It is said that they have a common root. So this may have two roots, this will have two roots, this will have two roots. One root is same, one root is common. One root satisfies both the equations. That is called common root. Then let the common root be alpha. Then alpha satisfies both the equations now. Substituting alpha, a1 alpha square plus b1 alpha plus c1 is equal to 0. Substituting in the second equation, a2 alpha square plus b2 alpha plus c2 is equal to 0. Now you solve these two in this method. What will get? Coefficients are same, no? Is it not? So no need to write this again. D1, D2, D3 are clearly there. In place of x you will get alpha square by D2 is equal to, next is what? In place of y we have alpha by D3. Next is 1 by D1. Then alpha square is equal to D3 by D1 and alpha is equal to, cross multiplying, D2 by D1 here. Alpha square is equal to D2 by D1 and alpha is equal to D3 by D1. If such alpha exists, For any two equations you can follow this method and get alpha square and alpha. But if there is a common root, then square of this must be equal to this. If this alpha and that alpha are different, then there is no common root. So what is the condition for common root? Square of this, that is d3 by d1 whole square, which is alpha square, it should be same as this alpha square, is equal to d2 by d1. Cross multiplying by d1 square, you can write it as d3 square is equal to d1 d2. So you have to remember the condition in this form. So the same point, this is for calculation of the solution, d1 is this, d2 is this, d3 is this. Okay. The condition for common roots is d3 square is equal to d1 d2. So if you want to write complete condition, d3 means what? c1a2 minus c2a1 whole square plus, sorry, is equal to d1 a1 b2 minus a2 b1 whole square into not whole square, sorry, into d2. d2 is b1 c2 minus b2 c1. Okay, you can remember it in short form, d3 square is equal to d1 d2. Suppose you want that common root. If it is known that there is a common root, directly you can take the formula for common root as what? d3 by d1, calculate d3 by d1. Okay. But in many problems we do not use this condition. What we do is, we directly try to solve the equations if possible. If they have a common root, by solving the equations you must get the common root. Okay. So our approach is going to be like that, by directly solving the equations and trying to get the answer. Now let us take the second point. If both the roots of the equations are common, both the roots are common means what? If alpha and beta are the roots of this equation, then alpha and beta are the roots of this equation. That means equations are same. But it does not mean that a1 is equal to a2, b1 is equal to b2, c1 is equal to c2. For example, if you take x square minus x minus 2 is equal to 0, there are some roots minus 1 and 2. If I multiply both sides by 2, still the roots are same. So what is the condition? If both the roots are common, ratio of x square coefficients must be equal to ratio of x coefficients must be equal to ratio of constants. So the necessary condition is a1 by a2 is equal to b1 by b2 is equal to c1 by c2, if both the roots are common. Okay. Now let us solve problems on common roots. First question, if the two equations x square minus kx minus 21 is equal to 0 and x square minus 3kx plus 35 is equal to 0 have a common root and k is greater than 0, what is the value of k? Let us not apply the condition. What I will do? I will try to solve the equations. Write the first equation, x square minus kx minus 12 is equal to 0. Second equation, x square minus 3kx plus 35 is equal to 0. Solve the equations. You can directly subtract and cancel x square term. This minus this will be 2kx minus 47, no? 35, oh it is 21. I commit lot of calculation mistakes. Now subtracting, what you will get? 56 minus 56 is equal to 0. Then what is that common root? X is equal to 56 by 2k, that is 28 by k. If at all there is a common root, that common root must be 28 by k. Now how will I get the value of k? I can substitute this common root in any one of the equations. Now I will substitute in first equation. X square means what? 28 square. I have to calculate, I do not remember. 28 into 28. $784, if I am correct. Okay, 784 by k square. Next, minus kx means minus 28. Minus 21 is equal to 0. So I will get 784 by k square is equal to 49. We know that 49 is 7 square. So let us keep this as 28 square only. 28 means 7 into 4. So 28 square means 7 square into 4 square by k square is equal to 7 square. 7 square cancels. So we get k square is equal to 4 square, then k is equal to, given that k is positive, so I have to take the positive square root, so k is equal to 4. Otherwise you will get two values of k is equal to plus 4 minus 4. So this is how we solve the questions and you can avoid that long condition. Next, again similar question. If these two quadratic equations have a common root, then k is equal to. Here the problem is x square coefficient contains k. In the previous question we could cancel x square term directly by subtraction. Here it is not possible. So what shall we do? You can cancel term of x, but you will get x square, then taking square root and you have to substitute in this equation. It is not that comfortable. So what we can do, in order to cancel these two, we can multiply this by 3k minus 8, this by 2k minus 5 and do, but instead of that applying the condition will be better. What are the coefficients? 2k minus 1, 2k minus 5, minus 4, minus 15, coefficients of the first equation. Next 3k minus 8, minus 5, minus 21, and first coefficient should be repeated, 2k minus 5, 3k minus 8. Take arrows like this. Now this is d1, d2, d3. I will write separately. d1 is how much I will calculate this into this, minus 10k plus 25 minus of minus plus 4 into 3k 12k minus 32. How much I am getting? d1 is 2k minus 7. Okay. Now d2 is this into this, how much? 84 minus 75, how much? 9. And d3, you calculate d3 and then you substitute in the equation the condition d3 square is equal to d1 d2, and you will get a quadratic equation there. Okay. I hope you can calculate, you can solve the quadratic equation and get the value of k. Okay, nothing is there. So I will move on to next question. If the equations x square plus ax plus bc is equal to 0 and x square plus bx plus ca is equal to 0 have a common root, then what is the value of a plus b plus c? Let us write the equations. X square plus ax plus bc is equal to 0, x square plus bx plus ca. These two have a common root. Let us try the first method only, no condition, because x square term can be directly cancelled. I will subtract these two and get the common root, if there is a common root. Subtracting, I will get a minus b into x plus, here c is common, plus c into b minus a is equal to 0. Then you will get a minus b into x is equal to c into a minus b. Is it not? If it goes that side, b minus a becomes a minus b. Now, in the question it should be given a, b, c are distinct. Then a minus b cancels, we will get the common root as c. So, if they have a common root, the common root must be c. So, c should satisfy the given equation. I will substitute c square plus ac plus bc. Cancelling c now, you will get c plus a plus b is equal to 0. Therefore, if they have a common root, the value of a plus b plus c must be 0. First option is correct. Next question. Again, same equations. If they have a common root, the other two roots satisfy which equation? This is a different model. Let us see that equation. Already we got the condition a plus b plus c is equal to 0. So, I will directly use that condition. A plus b plus c is 0. Okay. Now, if you substitute a as minus of b plus c in the first equation becomes x square minus of b plus c into x plus bc is equal to 0, is it not? Then clearly what are the roots? B and c. It is in the form of x square minus sum of the roots into x plus product of the roots is equal to 0. Okay, I got the roots of the first equation as b and c. Similarly, in the second equation, if we substitute b from this as minus of a plus c, you will get minus of a plus c into x plus ac is equal to 0. What are the roots? A and c. So, clearly the common root is c, or no need to calculate like this. Already in the previous calculation, we already got the common root as c now. Product of the roots of the first equation is bc. Common root is c. So, what is the other root? B. Other root of the first equation is b. Similarly, in the second equation, what is the product of the roots? ca. Common root is c. So, what is the other root? A. So, the other roots of the equation are a and b. So, what is the quadratic equation whose roots are a and b? Quadratic equation whose roots are a and b will be x square minus of a plus b into x plus ab is equal to 0. X square minus sum of the roots into x plus product of the roots is equal to 0. Since a plus b plus c is 0, a plus b is minus c, then this becomes x square plus cx plus ab is equal to 0. So, answer is second option. Next question, it is a very good question. If a, b, c are in GP, then the equations ax square plus 2bx plus c is equal to 0, dx square plus 2ex plus f is equal to 0 have a common root if d by a, e by b, f by c are in which progression? Already have explained about AP, GP, HP some briefly. If a, b, c are in AP, b is equal to a plus c by 2. If a, b, c are in GP, b square is equal to ac. If a, b, c are in HP, b is equal to 2ac by a plus c. All these things I have explained. Now, one method is you can apply the condition, that long condition, and get the answer. But let us try in a different way. Given that a, b, c are in GP, then what can you observe? In the first equation, what is the discriminant? Discriminant of ax square plus 2bx plus c is 4b square minus 4ac. If a, b, c are in GP, what is the condition? B square is equal to ac. What is this then? If b square is equal to ac, 0. Therefore, the roots of the first equation are equal. Therefore, the equation ax square plus 2bx plus c is equal to 0 has equal roots. Okay. Now, if I want that root, suppose alpha is a root of this equation, second root is also alpha. That means this is a perfect square. Roots of the first equation are alpha and alpha. Then what is the common root? That must be alpha only. That alpha should satisfy the second equation. Is it not? So, I want that common root alpha. Here, what is the sum of the roots? Sum of the roots is minus 2b by a, is it not? And if you want common root, both the roots are equal, no? Alpha plus alpha, alpha plus alpha, 2 alpha is this. What is alpha? The common root is half of this, that is minus b by a. Now, this minus b by a should satisfy the second equation. I will substitute it in the second equation, then substituting minus b by a, what will get? D into b square by a square minus 2be by a plus f is equal to 0. Now, we have to carefully modify this equation into some relation between d by a, e by b, f by c. If you want to, if you get a relation between these three, then you can identify the answer. So, I want, see, we have d by a, e by b, f by c. Now, we have b square here, d by a is here. So, I have to modify. I want to eliminate b, because d by a square is there, d by a should be there. I will substitute b square is equal to ac in the first term. Then d into ac by a square minus this term I will try to get E by B here. Already B is there, A is there. Now I can substitute A as B square by C minus 2BE by B square by C plus F cannot be modified, only single term, so plus F is equal to 0. Then here A cancels, here 1B cancels, simplify DC by A minus C goes up to EC by B plus F is equal to 0. Now dividing by C, you will get D by A minus 2E by B plus F by C is equal to 0. I will write it in the next page. D by A plus F by C is equal to 2E by B. D by A plus F by C is equal to 2 E by B. You know that this is the condition for AP. What are in AP? Therefore, D by A, E by B, F by C are in AP. What is the asked question? D by A, E by B, F by C. Same. So correct answer is first option. Okay. So with this we are going to conclude this session for today, and we are going to continue in the next class. After solving few more problems in the next class, we are going to discuss about quadratic expressions, graph, its maximum values, minimum values, solving quadratic inequalities, etc. Okay. So thanks for watching.